Okay, so this is my attempt at making a drawing. So here we have a beaker that we're heating up with water. So the water's really hot. We're going to heat up a metal. We're going to do this in lab. We're going to heat up a cube of metal, okay, and use a hot water bath to do so. And we're going to assume that after we leave it in there for a certain length of time, the temperature of that cube is the same as whatever the water bath is. So we're going to leave it in there long enough for all the atoms of that, or molecules of that cube, to heat up to the desired temperature. We're going to place it in a container of water in a coffee cup, and we're going to then see what happens. So if the temperature would have started out at 30, and I put this in here, if it was warmer than 30, it's going to go up, right? The temperature is going to eventually equal. Okay, it's going to absorb energy, heat. The water is going to absorb heat from the cube, right? So the water is going to go up, and the cube is going to go down, and eventually they'll be equal to each other. With that concept in mind, we're able to look at examples 8 and 9. So we have 30 grams of water. That's 280 kilokelvin, and it's mixed with 50 grams of water. That's 330 Kelvin. So we have cooler water being mixed into warmer water, or warmer into cooler. It doesn't really matter which way we're going to go. So we're going to be able to say that Q equals to Q. Heat is being transferred from warmer substance to a cooler substance. So we're going to take Q equal to Q. So we're going to call this Q of 280 Kelvin. Actually, better yet, let's do it this way. Let's do Q of 30 grams equal to Q of the 50 grams. Okay, now, which one is transferring heat to the other? Whichever one is warmer, because heat transfers from warmer to cooler. Okay, so which one is warmer? Well, we got to talk about what Kelvin temperature is. It's just another unit of temperature, but we're going to deal with units in Celsius, so we're going to have to convert. So we're going to take and convert 280 Kelvin minus 273.16. This is the conversion factor, if you recall from first year chemistry, to get from Kelvin to Celsius. So 280 minus 273.16, and we're going to do 6.84 degrees Celsius. Okay, and technically this would be 7 degrees Celsius, but we're not going to be that picky about sig fig, so let's pretend that has at least 2 decimal places past it. And then we're going to take 330.0 Kelvin minus 273.16. So 330 minus 273, all we're doing is converting into Celsius here, is going to be 56.84 degrees Celsius. Okay, so which sample size is warmer? Okay, the 50 is warmer, so that's going to get the negative. It's going to release heat to the other side, right? So this is releasing heat because it's warmer. All right, so then what really this is we think of this as Q, remember, is M times C times delta T. And this is negative M times C times delta T, because that's what Q stands for. This is always going to be, in this example, the 50 gram numbers. And this side will always be anything that's related to the 30 gram sample. So we're going to take 30.0 grams of water times 4.18 joules per grams degrees Celsius. That's specific heat of water. And then I got to do TF minus TI equals negative. I would leave this outside the parentheses until you need it. So 50.0 grams times 4.18 joules over grams degrees Celsius. And this is going to be TF minus TI. Okay, so all I've done is applied these formulas. Okay, I'm going to take a moment to clean up the conversions just so we have space to see. Okay, now we got to put in some more values here because we can't have a TF and an unknown TI. Remember that we said eventually their final temperatures will be equal. I'll stop transferring heat to the cooler and they'll be set equal. That's what that concept is. So we got to have initial temperatures. So as I read this, okay, we're going to go and figure out what our initial temperature was. Oops, I shouldn't have deleted that because I didn't write that down anymore. Okay, so before I deleted that, I went back and undid that. I know that my initial temperature of my 30 gram sample is 6.84 degrees Celsius. Okay, and my initial temperature of my 50 gram sample was 56.84 degrees Celsius. Okay, so now I can go ahead and actually delete this because I don't need it or erase it. So now we have, to clean this up, 30.0, no, sorry. Very annoying that it always changes thickness, but that's okay. 30.0 grams times 4.18 joules per grams degrees Celsius. Notice I'm always putting units in there. That's expected from you also. Equals, I'm going to leave this negative out here. I'm going to exaggerate my parentheses just to make a point here. All I'm doing here is cleaning this up. Okay, so now we're going to work through this math for the next piece. And we're basically just going to work with getting the TFs together, our terms together. So we're going to first we're going to multiply this. When I multiply this, the units of grams will cancel. So I'm going to take 30.0 times 4.18. Just going to do the number outside the parentheses. So this is 125.4, and I'm not doing a very good job with sig figs, but that's okay. We're just going to keep the number on our calculators for now. Again, I'm going to show you more steps than you necessarily need to write. Don't have to write them, but I would write what you need so you can handle the algebra. So what I did is I multiplied 30, I'm going to double check myself, times 4.18, and I got 125.4 joules. Right, grams cancel, joules per degree Celsius. I still have this. I'm going to multiply that first piece in front too, so 50 times 4.18. I left my negative out here. I'm going to leave that out there until I need it. So 209, again, grams would have canceled, joules over degrees Celsius. Still have TF minus 56.84 degrees Celsius. All right, now I have no choice. I have to distribute. So I'm going to distribute this. So this is going to become 125.4 joules over grams degrees Celsius TF minus, I'm going to distribute, right? So 125.4 times 6.84. And I'm going to do 857.736 joules, because when I multiply these, degrees Celsius would have canceled, equals, I'm keeping that negative out here still, 209 joules over grams degrees Celsius TF. I'm distributing again on this side. Okay, so 209 times 56.84, and this is going to be 11879.56, again 56 joules. Okay, so I distribute 209 times this is 209 TF, 209 times that gives me that. All right, now I'm going to deal with my negative symbol. Again, showing you more work than you might need to show, but I recommend that you show everything, at least an example, maybe not everything in your homework. Now all I'm doing right now is distributing my negative symbol. This side, it would remain as it was. Now I'm going to combine like terms on each side of the equal sign. So I'm going to put my TFs over here. To do that, I'm going to add 209 joules degrees Celsius TF to both sides. Okay, so that math is going to be 125.4 plus 209. So I'm going to get 334.4 T, let's put our units in there, joules degrees Celsius T sub F. This is still here, 857.736 joules equals, this went away, so this side is going to be 11,879.56 joules. So now I'm going to combine like terms, continuing on that path of combining like terms. Really having trouble writing my sixes today. Okay, so I have TFs over here on the left. I need to get non-TFs on the right. To do that, I'm going to add 857.736 joules to both sides. So I'm going to take 879.56 plus 857.736, and on that side I'm going to get 12.737, and I'm not doing sig figs at all here, but that's fine. You can just write what's on your calculator or not worry about clearing it. On this side, remember that we had 334.4 joules per degree Celsius T sub F, right? Because this is going to go away. And I have this, and now I can mathematically divide both sides by 334.4 joules degrees Celsius. And divide this side by 334.4 joules degrees Celsius, which will give me 38.09 degrees Celsius. Because think about the units here. On this side over here, we have joules over joules degrees Celsius, so then that's the same thing as joules over degrees Celsius. Flip that bottom unit. That's how I get the units of degrees Celsius.